So 4 is going to start to get us into the graphing mindset once we get through this little bit of vocab first. So standard form is where the highest degree goes down to the constant. So when a polynomial is ordered from highest degree to least degree, which is your constant value. So I'm just going to give you an actual numerical way of doing it. So if we have like 7x to the 5th minus 6x to the 4th plus 5x to the 3rd minus 4x to the 2nd plus 3x minus 2. So we are starting 5, 4, 3, 2, 1 in terms of the exponents, and we are leading from the highest one down to the lowest one, which is a constant. The leading coefficient is the coefficient of the term of the highest degree in the polynomial. So for example, if I say 8x to the 3rd plus 15x squared minus 2x plus 6, this would be the highest degree right here, which means your leading coefficient has to come in front of that term, which would be 8 in this case. So for the first example, it says state the degree and the leading coefficient. So if we have the degree and then leading coefficient. So remember, when we did degree in the previous section, that's the highest power or the highest monomial power that we have. So the degree would be 3, because this is 3, this is 2, and this is a 1. So 3 gets that. And then the leading coefficient has to come in front of that term, which would be 7. For B, the degree would be 6, because that's the highest one. And then the leading coefficient has to come in front of that, which would be -8. It can be a negative value. So that would be -8. So a polynomial function is a continuous function that can be described by a polynomial equation in one variable. So we can evaluate functions for variables and algebraic expressions. So this is where it says find f of x minus 2 if f of x equals x squared plus 7. So if I just recopy this problem down, and the question is asking us to find x minus 2, that means wherever there is an x, we are replacing it with x minus 2. In this case, though, this is a FOIL situation. Keep in mind that there are 2 of them, so don't forget that. So when we FOIL them out, we get x squared minus 2x plus 4 plus 7. So that means when we combine like terms, f of x minus 2 equals x squared minus 4x plus 11. Now for 3, we've got 2 things here, p of 2a minus 1 and p of a. So you absolutely can do them separately if you want. You can do them separately. So if we do p of 2a minus 1 first, that means wherever there is an x, I am putting a 2a minus 1 in, and there are 2 slots for that, so just keep that in mind. So this is, again, a FOIL situation. So when I FOIL this, I get 4a squared minus 4a plus 1. But not only do I have to FOIL, I also have to make sure I distribute that too. So I get 8a squared minus 8a plus 2 plus 2a minus 2. And then I combine like terms one more time. So 8a squared minus 6a, and my 2's actually cancel out. So now I'm going to do the same thing with p of a. This one's a little bit easier. There isn't really much to do here. So I get 2a squared plus a minus 1. But then the question was saying it's p of 2a minus 1 minus p of a. So what I'm doing is taking the 2 terms and I'm subtracting them. So just don't forget that that second term, make sure you have a parentheses around it, because you're going to have to distribute that negative sign to all of those terms that are there. And then your last step would just be to simplify and put all the terms together that can be going together. So we get 6a squared minus 7a plus 1 for that particular problem. Okay, if you want to do them separate and then join them together, absolutely do that. All right, so 4 is a little bit more, it's very similar to that one. So what I want you guys to do is to pause it, try each one, and then come back and double check with the answers that I'm about to write. But I'm just going to give you the final answers here. You can see the written out answers on my detailed key. But what I want you to do is to actually do it yourself. All right, so I'm just giving you the final values that I would get. Make sure also you got a 0.5 here multiplied. So when you put everything together, you do get these hideous numbers. But that would be what your final answer equals. So where this now leads us is to now start talking about graphing and describing graphing. So these are just 6 common functions that you might be encountering. Many of them, we've done constant, we've done linear, we've done quadratic and cubic. The other 2, the quartic and the quintic, those are pretty much new. But you'll find that they do fall into the similar categories as the quadratic and the cubic. All right, so when we talk end behavior, the domain for any polynomial, domain, that's the x values, is all reals. So all real numbers. So that's negative infinity to positive infinity. The range and end behavior of a polynomial, it's determined by the degree and the leading coefficient. So, and the leading coefficient. If you want to abbreviate that LC, you certainly can do that. So the behavior of the graph of f as x approaches infinity is written, positive infinity that is, x approaches positive infinity. For negative infinity, it's x approaches negative infinity. And that's the type of symbols that we're about to be using. Now, the top of the next page goes over degree, leading coefficient, and end behavior for each of these types of situations. And these are your 4 situations you're going to encounter. Now, one thing you probably also want to add, is if we think of quadrants, here's our 4 quadrants. First quadrant, they're both positive. Second quadrant, the x is negative, the y is positive. Third, they're both negative. And the fourth, the first value is positive, the second value is negative. That's going to help you dramatically in terms of writing statements like these guys, okay, for all of them, because x is x and f of x is y. So if you have an even degree and a leading coefficient that's positive, that's like an upwards parabola, like in this first box right here. Well, in terms of behavior, end behavior, this one ends in quadrant 1, which means they should both be positive. So as x approaches positive infinity, f of x approaches positive infinity. And remember, f of x is just y, so they should both be positive. Whereas on the left-hand side, you're in the second quadrant. So x should be approaching negative infinity, and f of x, or y, should be approaching positive infinity. Same scenario, degree is even, but now the leading coefficient's negative. It's an upside-down parabola, and you're in quadrants 3 and 4. So obviously the values are going to change. In the third quadrant, they should both be negative. In the fourth quadrant, the x is positive, the y is negative. For an odd degree, but a leading coefficient that's positive, you're in the first quadrant and you're in the third quadrant. So first quadrant, they're both positive, which they are. Third quadrant, they're both negative, which they are. So they match. That's why it's important to go over the signs in each different quadrant of the xy axis. If the degree is odd and the leading coefficient is negative, then you're in the second and the fourth quadrant. And the values that you write should relate to that. Now, for real zeros of a polynomial occur at the x-intercepts. An odd degree function will always have an odd number of real zeros. An even degree function will always have an even number of real zeros or no real zeros. So even degree right here. First graph never touches, so there's no zeros. Second graph, though, we've got 1, 2, 3, 4 zeros. So it crosses 4 times. So that's a 0 situation and 4. Whereas odd, it always needs to be an odd number. So there's your 3, or there's your 1 for that. So the last bit of this notes is now going to help us have us really focus on this chart right here. So if you're able to keep them next to each other or look at one online that I have on my notes, whatever you can do just so that you can see the information while we're answering each of these questions. So there's 3 parts to these last 4. We're going to describe the end behavior, determine whether it's even or odd, and we're going to state the number of zeros. So I'm going to write the end behavior on the actual graph itself. And for me, I like to actually flip-flop the values to keep them in order, because when we write stuff, typically we write x's before y's. So for A, if I look at this arrow, I'm in quadrant number 4. Well, that means my x should be positive and my y should be negative. So my end behavior is as x approaches positive infinity, f of x approaches negative infinity. And there's my end behavior for that. For the guy over here, I'm in third quadrant, so they should both be negative. So as x approaches negative infinity, f of x approaches negative infinity. So that's part A. For B, I have to determine even or odd. So let's count the zeros. 1, 2, 3, 4. There are 4 zeros, which actually answers part C, which means that this is an even degree. You also know it's even because they're both ending down in the same direction. For B here, we've got end behavior. So for this guy, I'm in quadrant 2. So as x should be negative, approaches negative infinity, f of x approaches positive infinity. And on the right-hand side, I'm in quadrant 4 again. So as x approaches positive infinity, f of x approaches negative infinity. Now I have 1, 2, 3 zeros. So those 3 zeros mean that I have an odd degree. You also know that because the graph begins and ends in a different direction. All right, for C, behavior. This one, I'm in first quadrant, so they should both be positive. So as x approaches positive infinity, f of x approaches positive infinity. And down here, I'm in negative. So as x approaches negative infinity, f of x approaches negative infinity. There is 1 0, which means if there is 1 0, this is an odd degree. Plus, again, to double check, the ends of this graph end at different locations. Now, for your final one, we still have end behavior here.